right, so now we're going to talk about horizontal asymptotes. All right, so the first thing you want to do here is you want to figure out what the leading terms of your numerator and your denominator are. After you do that, then you can figure out what the numerator and denominator degrees are. The degrees will determine what if you have a horizontal asymptote or not, and what it is. So the first thing we've got here, we have an f of x. Our function is already factored out for us. But whenever you're doing horizontal asymptotes, you actually don't want it factored out. So instead of working the entire problem out, okay, I'm going to do that real quick, but then I'm going to show you what we can do with that. So just watch this for a second. If we go over here and we do distributive property, we would get 3x minus 24. If you do distributive property or FOIL over here, you're going to have your 3x times x, which is 3x squared. Then you'll do your outer terms, which is negative 24x. Then you'll have your inner terms, which is negative 10x. And then when you take last times last, you get a positive 80. Now, if you'll notice that this x right here has an exponent of 1, and this actually has an exponent of 0. Okay, there is no x. And then you'll notice that the exponent is 2, and then it drops down to, we could put these together, and that has an exponent of 1, and then there is no x, so that's really x to the 0. When you multiply, when things are already in the order from like biggest exponent to smallest, when you multiply them out, do you see how 3x times x gives us our leading term where the exponent is the biggest? Okay, so over here, when you take, if you think about this 3 actually being in parentheses, because that's a factor, when you take this lead term in that factor times this lead term, you get the first term. All right, so instead of having to multiply all of it out like I did right there, okay, you actually don't have to do any of this to find a horizontal asymptote. All you need to do is take each term, the biggest degree term in each factor. So the degree, if you remember the degree, that is your the most letters being multiplied. So you're looking for letters. In this case, there is no letter, so it's just a 3. But if you have a variable, it's the variable with the biggest exponent. So if we multiply on the top there, if we multiply the 3 and the x together, we get 3x. I think I'm going to use a different color. And then we would have stuff behind it. When you go down here to the other one, in the 3x minus 10, this variable has the biggest exponent, and this variable has the biggest exponent in each of your factors. So if we multiply those two together, we get 3x squared. And then yes, you will have stuff behind it. All right. When we're doing horizontal asymptotes, we only care about the first term, the term that has the largest exponent on your variable. So what we do from there is we look at the degree. So the numerator, the top, has a degree of 1. The denominator, its biggest variable exponent is a 2, so it has a degree of 2. So the numerator has a degree of 1, and the denominator has a degree of 2. So we compare those two. Well, 1 is less than 2. So since 1 is less than 2, our numerator degree is less than our denominator degree. The top degree is smaller than the bottom, which means the horizontal asymptote is y equals 0. So this has your horizontal asymptote, and it is at y equals 0. All right, so let's go and look at another problem. And I'm going to go ahead and put the 2, I put the 3 in parentheses. I'm going to put the 2 in parentheses to remind you that that is actually a factor, okay? Do not forget about those out front. They are factors also. All right, so if we are going to try to rewrite this, where we're just looking at the first term, the term that has the biggest exponent, so there's a 3 in this one. 3x would be your leading term here, has the biggest exponent, and then this has the biggest exponent. So if you multiply those 3 things together, 3 times 3x times x, you get a 9x squared. Yes, I realize that there's more stuff behind it if you continue to multiply, but that's the first term. That's the one we care about. Then in the denominator, we have a 2. This one has the biggest exponent, this letter does, and this letter has the biggest exponent. So if you multiply those, you get a 2x squared. And yes, there would be stuff if we multiplied it all the way out. So now we're going to talk about the degree. So the degree here is the biggest exponent, which is 2. And this degree, which has the biggest exponent, is also 2. So in this case, the 2 degrees are equal. Okay, so these are equal. So on the other page, we call them m and n. Okay, so the numerator degree we call m, and the denominator degree we call n. I'll go back so you can look at that. All right, so, well, I don't have it on this page, but it's on your notes. All right, so when they're equal to each other, when the numerator and denominator degrees are equal to each other, we're going to have y equals a over b. So our horizontal asymptote will be y equals a over b. All right, so my notes on this video, they are just reminders of what you see on your actual notes. So A is your lead coefficient. Okay, so that is your lead coefficient of the numerator, and B is the lead coefficient of your denominator. Here is the lead coefficient of your numerator, and 2 is the lead coefficient of your denominator. So y equals 9/2. So your horizontal asymptote would be y equals 9/2. Now, the only one I haven't talked about is when the numerator degree is bigger than the denominator degree. So what that's talking about is, let's say that you had f of x equals x squared plus 4 over x minus 2. All right, if you had this, do you see how that degree is bigger than this degree? So that's when you don't have a horizontal, you have no horizontal asymptote.